Welcome to the final part about Geographic Information Systems, GIS, how to present data or cartography. To repeat a little bit what we have done so far, GIS have four main functions: to collect data, to store and manage data, to analyze data, and last not least, to present and communicate data. And for this purpose, the communication of geodata, we can learn a lot from the wide field of cartography. It is almost an art to create a good legible map, and this art is to display as much as the viewer can understand, but at the same time avoiding overload of too much information. So this already implies that you really need to know who is the target group of your map. Who are you making this map for? Especially consider the difference between lay people and experts. For experts, you can put much more information into a map than you can do for lay people. Another basic principle of GIS, and think back to Ian McHarg, whom I had quoted in the first lecture, is the principle of organizing data in layers. So we can visualize multiple data layers, for example, vegetation, water, and towns on the left side. And any GIS, ArcGIS, QGIS will supply you with a number of tools and options for sophisticated map design. When you start presenting data, first think about the type of data. Is it quantitative data or is it qualitative data? For example, data in different categories like land use. Here we start with quantitative data. And if you have quantitative data, for example, the population density per county, or the number of inhabitants per county, or the proportion of forest and overall land use per county, there are various ways to present this. You can use a color gradient, from one color to another, here on the left side from yellow to dark red. You could use symbols, especially playing or changing the size of a symbol in the middle. The bigger the circle, the more inhabitants. And last not least, you can use diagrams. Here a pie chart showing the proportion of forest, the green part, as part of the overall land use in yellow. If you have qualitative data, you can also use colors, but then maybe different colors for different categories instead of a color gradient. You can also use different symbols, symbol fills, and different shapes and sizes. This graph or this illustration is based on the work by French cartographer Bertrand, and I highly recommend his work. He looked into these different variables for map presentation in detail and how you can use colors, symbols, shapes, and size to communicate quantitative and qualitative data. When you plan your map, think about the following questions. What do you want to say, and to whom do you want to present your data? So what's the core message and who is your target group? Then keep the focus, reduce the content to the really important things. Define your map as well as possible. What's in the map? What level of detail do I need? Where is the information from, etc. Use an appropriate scale. And here we speak about data generalization in cartography. On certain scales, you can generalize items. So for example, you will not represent every single tree on a regional map. Very simple example, but of course there's a lot of gray area, and in the end that's one of the most important decisions a cartographer has to take. Where do I draw the boundary? What do I generalize and what do I still show in a map? And again, this also depends on your target group. Use descriptive elements, and there are 5 basic elements you need in every map. It's a title, the legend, a scale bar, north arrow indicating the orientation of the map, and a source. Where is this from? And last not least, balance aesthetics and aesthetic perception in map design. So really good maps are also pieces of art. This here is an example by my colleague Alistair Ray from the UK. You find him under the pseudonym Under the Radar, and he is giving a lot of QGIS instructions and tutorials. And this is a map built in QGIS showing the amount of greenbelt for the northern English city of York. Greenbelt is a British planning tool to prevent urban sprawl. So in the green area, developments are restricted. You have an orientation map in the top right that's showing you already where York is positioned in relation to the UK or to England. And then you have the map of York, just the basic information you need for this topic, urban sprawl and planning legislation. You have the areas that are greenbelt in green and not greenbelt in yellow. And in black, you have the settlement areas derived from building footprints. And for orientation, you have the main roads and the names with the name of the main city, York, in a larger font than the small suburbs. You can see the main the main information already in the top left in a big number, 82%. And here please note that this is rounded. Often GIS is giving you numbers like 82.35709%. Those numbers behind the comma are pretending a false accuracy that we don't have, and they're useless for your reader. So decide on where to round your numbers, what to present and what do I not present. Then we see the title, it's about greenbelts and where York ranks in comparison to other British cities. It is number 11 out of 186 local authorities that have greenbelt land, where number 1 has the highest proportion of greenbelt. So we can already see in one look, York has, in comparison to other British cities, a very large proportion of greenbelt land that is not allowed to develop. I suggest you're not using more than 3 different fonts in one map, but use different font sizes for title, captions, explanatory text, for example. You also need a scale bar. Only with a scale bar people can measure on a printed map, and also you really need a scale bar to get an idea of the dimensions and distances on the map. Normally I would also add the scale. That's not written here, but possibly you want to add that. In the bottom right, you have the copyright source notices. That's an important topic. Most geodata is not free, and if you use it for your own work, sell your work, then you can get into real big legal trouble. This would be a different lecture here, talking about copyright and how to reference geodata, but you must keep an attention to this and always provide the source of your data. So overall, I think this is a very good example of a well-presented map. And last not least, we have other possibilities. So for example, we could derive 3D environments, even interactive environments, virtual reality environments from geodata. This is a laser scanning model. You can see it at the trees. It's typical for the reflection of laser scanners, how the trees are shown here. And these allow almost photorealistic real-time environments, but you could also use a third dimension to communicate a different variable. So there are additional options of presentations if we move into the 3D space. I've done a lot of work on 3D visualization of maps and geodata, so if you're interested in this, please look for my other work and publications. Last but not least, a couple more examples, especially in the context of climate change, since our course is about using GIS in climate change. Here we have mapping of urban heat islands, and it shows us another basic principle. That's associative colors. Here, tree cover is depicted in green and the urban heat islands in a gradient from yellow to red. You remember quantitative data rate gradients. And everybody or most people will associate the green shades of green with cooler areas and the yellow to red with warmer areas. And that's intended here that you immediately see, okay, the green areas are cool, the yellow to red areas are hot. We have a couple more examples on the right side from the Philadelphia Climate Smart Cities project, and some of them are also addressing urban heat islands and the link to health and social issues. And usually green is positive. For example, in the context of heat islands cooler, red is negative. It's a typical traffic light scheme, green, yellow, red. But be careful if somebody in your audience has red-green blindness, then this could be counterproductive. If not, then a traffic light scheme is often communicating this message that green is good and red is bad and yellow somewhere in between. Here we have a zoom into one of these maps, and again you can also see it has a title, Lack of Spaces Together. A pretty smart title, with a little pun included. It has a legend from green to the gradient yellow to red. So here we have a combination of gradient and distinguished colors. We have a scale and the scale bar in miles because it's an American map, a north arrow, and the source or description in little explanatory text. And this is it for now. Of course, this is only a very, very, very short snippet of information about cartography. It's a large field. You can study it. You can read very good books about it. I could recommend the works by Bertrand, by Goodchild, and others. And you can even study it in its own course. So I hope I have raised your interest and close this introductory course at this point. Thank you very much.